And hello, welcome to this video of OPCUA. Okay, so in this video, I want to talk about yes. Let me zoom out a little bit. Yeah, in this video, I want to talk about the UA-Net model compiler. Okay, Kutsai in his videos under Industry 4.0 TV, he did talk about UA model compiler before. He did it very quickly and he used PowerShell. And you might be wondering, is it possible to do it on Windows? I mean, do it on Linux and not just Windows? Answer is yes, thankfully yes. So you can do it in Linux, and I'm going to show you how I do it on my Linux setup, Arch Linux. So you should be fine. Now, just a warning for you. This thing can get kind of lengthy and tedious. And if you're and you might be wondering why you must put in all this extra effort. Because if you take a look at C# OPC code, okay, C# OPCUA code, if you take a look here, yeah, let's see. Yeah, this is the typical UA server under our demo server. How many lines of code are there? Okay, 345 lines. Okay, 345 lines of code. This is just the UA server. And if you take a look, we have to also run program. The program file here is what, 100 plus lines of code as well, 150 plus lines. Again, not ideal. Why are we spending all this effort? And if you even take a look at the Rust OPCUA code, even the Rust OPCUA code is 125 lines in total. Okay, this is under log A9 OPCUA. He has made a Rust OPCUA server, very simple server. Now, C# is like slower than Rust, faster than Python. Why are we spending all this effort to get things on C#? Okay, and of course, yeah, Rust is more user-friendly even than C#, in my opinion. Yeah, and Python, of course, most user-friendly, but you can get lots of, it slows down, you don't have static typing, and I don't really like that. Okay, but why are we doing all this? Yeah, if you take a look at who's actually written the Python libraries, it's by this free OPCUA account. Okay, is this free OPCUA account? It says open source C++ and Python OPCUA libraries. Okay, this is our open source Python and OPCUA libraries. And then if you take a look at Rust, it is by this very smart guy, I guess, log A99. Again, made some very good repositories, but C# is made by the OPC Foundation, like the official OPC Foundation. Like, this is as official as you get. They comply to all the standards as far as possible. And if you look at all their repositories, well, there is a Java repository. There's a Java repository. There's some CSS here, which is, I don't think, even a OPCUA stuff. This looks like a website or something. GitHub.io. This is probably their what do you call, yeah, this does look like their website and stuff. It's not even in use. 7 years ago, last commit. Oh, not last commit. Last commit, 2019. That's almost 2-3 years ago. They're hardly using this anymore. Okay, but you see, everything else is written in C#. Okay, local discovery server C, sure. Everything else written in C#, C#, C#. Under .NET Standard, .NET everything, you know. Yeah, but .NET Standard is good because it's compatible with .NET Framework, .NET Core. It's very good cross-platform. So, I mean, yeah, it's not as fast as Rust. It's not as user-friendly as Python, but this is as official as you get. And if you want to talk about complying with the official OPCUA standards, then this is the way to go. That's why you're putting in this extra effort. So without further ado, yeah, let's talk about the workflow. Okay, the workflow is basically, you get this OPCUA model compiler. You need to build it using .NET Build, and you need to churn in, you need to supply this XML file right here. Okay, this XML file is the demo model. Okay, I have it open in NeoVim, and in case you're wondering why I'm having all these alphabets at the bottom, it's because I'm using NeoVim and I'm turning on screen key for your benefit in case you want to see what keys I'm using to navigate here and there in my NeoVim. Okay, I'm not using VS Code, I'm not using Visual Studio. Everything, majority of things on Vim, NeoVim, pretty much I have to do it on keyboard. So, and it's way faster, more ergonomic. That's what I like. Yeah, so here is the demo XML file which we need to feed into this model compiler. So that's what we're going to do. We're going to feed this demo XML file into the OPCUA model compiler. Okay, and I'll just demonstrate how we can run this thing before I delete this entire repository and clone it in front of you. Okay, so I'll just demonstrate how it's supposed to work. I'm going to make a directory called output. Okay, I'm going to make a directory called output. Okay, this is inside my OPCUA model compiler, what do you call it? OPCUA model compiler binaries. Okay, and I'll show you where to find this later, but this is the file that you need to use, or the EXE file. Oh, I don't need to CD. I should be using OPCUA model compiler. If you turn this on, you will see, okay, this is like just like any other console application. You can ask for help, so you can do it like so, help, and you'll just print this help message again. Doesn't really do much in the way, but the main thing we are going to do with this. Yeah, the main thing we're going to do with this is compile. Yes, the command that we are using is compile. So we're going to use compile, Control L there, compile, and then I can display some help. Okay, OPCUA model compiler, again compile and then help. So what's the help like? Okay, the main three commands I saw Kudzai use in this video is D2, which shows the path to the model design file, which contains the OPCUA information model. Now this information model is this XML file that we are talking about. This demo model.xml, it's available in the repository. You can use it to test it out. Okay, CG. CG is the file that generates the identifier file, which is some CSV file. So this CSV file is a file that contains the unique identifiers for the types defined in the UA information model. Now, good thing for us is that we don't need to write it out ourselves. We only need to write out this XML file, and we do need to spend a good bit of effort doing that, no doubt. But while we are there, I mean, we're supposed to have a CSV file first, I guess for compliance or for some other reason. But this thing actually generates that for us as well, in addition to the C# code and the noteset XML codes. Okay, so and then O2 is where our output directory is. Okay, so let's try this out. Okay, so what is our compiler here? Our compiler is here. This is our input file, which is our demo model XML. And then what we're supposed to do, okay, I'm going to push all my outputs to this folder. Okay, so I'm going to do OPCUA model compiler, use the compile command. Okay, the autocomplete isn't really that good here, so compile command, okay, I keep forgetting. Okay, first thing is D2. Okay, let's have a D2 option. D2 what? D2 this demo XML. Okay, demo XML. What's the next step? CG. CG is creates the identifier file. So let's just make this thing CG demo model.csv. Okay, CG demo model.csv is going to generate a CSV file for us. And last but not least, we'll have the output. So this is how you use the thing. So let's have the output. What's the output? Output is let's put it to the outputs folder. So this, see, output is just looking for a directory for the generated files. Let's just put it in the output folder. So I'm going to put dot this, that means this directory, I'm going to put it in the outputs folder. So I made a directory called output, and I'm going to chuck all my output files there. Oh, right. Why did I use a help? Okay, let me get rid of the help. Then you can see the thing. OPCUA model compiler, compile, you're trying to compile this input file, design file, I guess, this called D2 for design file. You generate this CSV, generate this CSV file, you output everything to this output. Let's see whether it works. Okay, well, that's very short. And if you ls the output, you'll see that all the CS files are there. And let's reload nerd3 and let's go to output. Whoops. Wait. All right. Pardon me for this. This is embarrassing. Okay, there we go. Control-Shift-C for changing it here. Let's go and take a look at the output folder. Under the output folder, we will have a number of things, like there are classes, constants, data types. All these are CS files which are auto-generated. Okay, these are auto-generated files. Okay, and then it has this system attribute here, and it's warning that there's some kind of duplicate or what, but otherwise, I guess it's okay. Okay, and then it's the data types already allows for whatever, so that means that these things are already, like, you know, present. But you can see that this actually generates things for us, auto generates code for us. So there are region object identifiers, data type identifiers, object identifiers, variable identifiers. Okay, apparently I don't know why my files are kind of, oh right, I think I know why. Okay, because I think yeah, my linter is telling me this is an error. There's a duplicate of these C# files elsewhere. I guess the C# files are inside the demo folder of the yeah, they are inside the demo folder of the demo model. See, under demo model, you see that all these output files are already here. So that's why it's complaining that, hey, why are you making extra duplicates of this same class, this same properties? Yeah, so but okay, basically we have constants, data types. Okay, you see heater status. Okay, where did that come from? It came from the demo model.csv. So you can see all these codes auto-generated for us. We do not want to write it ourselves, and I want to really reinforce that. Yeah, you do not want to write the node code yourself. Okay, why? Well, if you take a look in the program file, you try looking for node, you will see them actually handling NodeManagerFactories. You do not deal with the node yourself, you use NodeManagerFactories. So what is NodeManagerFactories? Okay, NodeManagerFactories are, well, if you took a look at the factory design pattern in general, factory design patterns are here to tell us, okay, if you have a class with several kinds of dependencies and you want to start assembling them together using dependency injection, the factory class is responsible for constructing those classes for you. Yeah, you do need to know about dependency injection, what that means. I'm not going to explain here. So yeah, lots of complex object-oriented stuff. But long story short, you're not going to deal with the nodes yourselves. Okay, you're not going to deal with the nodes yourselves. You're going to use node managers and node manager factories. Okay, so what's a node manager? What's a node manager factory? Right? Let me show you what at least a node. Okay, let me be sharp. Yeah, enter the node manager factory. Okay, node manager factory is right here under this interface iNodeManagerFactory. Okay, iNodeManagerFactory is an interface which is fulfilled by the NodeManagerFactories. NodeManagerFactories, as the name suggests, construct node managers. So what exactly are node managers? Okay, node managers, or rather, if you take a look at the interface, it's easier to read. So this is an interface to the object, which is a node manager that manages a set of nodes in the address space. Remember what nodes are. And if you take a look at the Python files, it may help you a little bit. Okay? Because if you try taking a look at C#, it's going to run you in circles. I can almost promise you that. Okay, so look at the server minimal .py, at least to get an idea of what a node is supposed to be. Oh, I already have this open here. Why am I opening here again? Go back. Okay, so you see how does the thing get constructed in the Python? So in the Python, you actually make a server object right here. You initiate the server, you set the endpoint, and you register over here the URI, okay, or URL, okay? So this is registering your own namespace. It says it's not necessary, but you should specify it, okay? Your endpoint is here, which is what you use to log in with your client to this particular address space so that you can find this server. Okay, then you start adding a node. Okay, a node is something that you sort of add an object to. So objects like in object-oriented programming, there are instances of classes. These objects themselves, they can contain variables, they can contain methods. So in this, can you see that we are adding an object here to the node? Okay, the object, you can actually add a variable, and you can actually add methods as well. I'm not going to go through in detail what these are, but you can add variables, you can add methods. So objects in this sense are stored under nodes. Nodes are like, well, if you take a look at this Python file, they're a bit like namespaces. So nodes have methods, nodes have variables, nodes have objects, but it's like a namespace that you host inside the OPCUA server. But I may be oversimplifying and butchering things. You should actually watch concise videos to see what the official definition of, or rather more correct definition of nodes are. So this is nodes as you see here in Python, not in the most correct sense, but something you can just sort of infer and make educated guesses. Oh, this is what a node does. All right, so in Python, you interact with the nodes directly. You try interacting with the nodes directly, you will get in trouble in C#. Because you see node managers here, okay, node managers, they have some namespace URIs. They manage a set of nodes. Okay, so the nodes, you don't really have I don't even see node objects here. You just manage a string of namespace URIs, and you look for this thing called node IDs. Okay, and you see the node ID objects. Okay, they appear over and over again. They're not just node ID like numbers and stuff, but okay, yeah, they're not just numbers. They are actually more than numbers in this C# case. So let's take a look at what this node ID is using OmniSharp. So I'm going to use OmniSharp. Go to definition, and here is where the ID is. If I open ls over here, okay, where is it? UA server AR is here. Ah, yes. Okay, UA NetStandard stack OPCUA call types built-in node ID.cs. So you can see that how deeply nested all these node types are. You do not want to go and figure out how to use them manually. You really don't want to do that. Okay, so you want to leave it to the design. I guess if they force it on you to do OPC a certain way, let's just follow. Because there's just too much effort to do it the manual way, manage one node at a time. You can see node IDs have very many constructors or overloads. You can have a node ID value, uint, unsigned integer value. You have a node ID with a value namespace index, GUID, byte value. Okay, so these are many ways we can use to start node IDs. Okay, let me use the keyboard. So this is the base constructor. These are different overloads of the constructor, And what does it inherit from? Well, it doesn't really inherit from anything, but it just implements these two interfaces. Okay, and is this a partial class? Oh, this is just a class. That means everything is all the codes over here. Okay, so there's an initialize method, there's a create method. You want to keep going down, and it gets more and more messy. Okay, so probably not the best idea to really deal with these node IDs yourself. Okay, we're going to use the official methods, build code that uses the NodeManagerFactories, and just let that you do what it does. Okay, let the NodeManagerFactory and let the NodeManager do their jobs, do both their jobs, and we will just use them. We will not try to explore all these classes. It just takes too much effort to try and manage nodes manually, just like in Python. So that's why we are doing this. Okay, so yep. And not only do you have C# file, you also generate all these node set files, which are important for compliance. You can see many types of many data types here, many methods as well. Has interface, has notifier, has subtype, a lot of aliases right here, model URI. So these things don't touch. Someone might use it, but we are generating it. We're not going to use it. Okay, this is a predefined, looks like some binary file. I don't know what it is, UA nodes. Okay, here's our XML file, predefined nodes.xml. Again, we don't have to write this manually, auto-generated. It's good, but I don't know if we are actually going to use any of it in C# programming. Okay, these are our types.